Hi, and welcome to SCOMathon 2025. In this segment, I will introduce you to some of my ideas on how you can begin to cultivate an alert strategy and begin to work actively in improving your alerts so that they provide better understanding and more insight for your customers and for your coworkers. My name is Thomas Beck, and I'm very happy to presenting here at SCOMathon again. I've been working with SCOM for the last 15 plus years, doing which I have developed more than 200 custom management packs and reports for both SCOM Configuration Manager and Service Manager. I'm focused on creating automated, self-correcting, condition-based monitors and runbooks, as well as report sites and interlinked reports that show different aspects of SCOM. They also function as a form of live documentation, which, according to me, is a very good way of handling your SCOM documentation. So, why would you do this? Well, in a perfect world, everyone already knows what to do. They know how to solve every error, how to get everything back online. One could even argue that in a perfect world, things just don't break down. But in our, well, more imperfect world, we sometimes need a bit of assistance in order to pinpoint exactly what went wrong and how it went wrong. And after that, we need to figure out how to solve it in the most optimal way. So we want to create an alert that helps us in this troubleshooting. And so this segment will focus on alerts in an imperfect world, alert handling, and better alerts, and how to work with these concepts. So, if we consider alerts in an imperfect world, where should we concentrate our efforts in an attempt to improve how we make the world a little less imperfect? Well, every alert needs an owner. The owner is the guy who gets the job of solving these alerts. This can happen in many ways, through fax, SMS, mail, or an ITSM queue system. As long as the alert gets solved, the method of alert delivery matters less, but it still matters and can still be improved. Every alert needs to be self-explanatory. So you need to write down what the alert is, what the alert means, and how you can solve this alert if possible. A solution can be to just call a friend from tech support or a super user of some sort. But then it needs to be written inside the alert so everybody knows that this is how you solve this alert. So it's always our focus to try and describe this alert as good as possible. In this manner, we give the person getting the alert a better chance of actually being successful in providing a fix. And this is something we want so that we can work better as a team. The Fool Me Once strategy. Well, it's essentially to write down your disasters, to write down the recoveries, and to use this knowledge to make better monitoring, so that you reduce the chance of having a repeat incident or a repeat problem. And, well, you're doing a better job if you're having more uptime. So, and you're doing a bad job when the customers are calling in telling us that something they are paying us for is not working. This is the most, the baddest case of monitoring you can imagine, is where the customers call in. So, alert resolution time matters. SCOM alerts are frozen in time, so they might not be what they were when they appeared. And not all alerts are handled in real time, so you might be looking at old data. And this is because things change over time. You know, the disk drive might have been running low on disk space, but once you get to the alert, it might be completely empty on disk space. And please remember that monitors SCOM and monitors can auto-create incidents inside your ITSM solution. And they can also auto-close these incidents again if you are experiencing a temporary blip, for example, that, I don't know, takes away connection to all your machines. Then you can create an alert, and then the connection comes back. Then you can auto-close this alert. This is how SCOM works. So this is, you take it a bit farther by putting the same kind of functionality inside your ITSM system. So when we look at how to handle alerts, we should look at the circle of an alert's life. An alert is born, and in a perfect world we know exactly who to assign it to. And so it gets assigned and eventually solved. So now it can happen again if needed. And as you see, this is a full circle of life or a full triangle of life, depending on your geometric perspective. Mostly it's probably just a triangle. So yeah. Alert handling 1, known error. We have two types of errors, known and unknown. If we look at the known alert first, we know it. We know how to fix it. We might even be good at fixing this one type of alert. But can it be automated? Could we make a solution that triggers on when the alert happens, so that it will auto correct the alert and it will go back to green? Yes, well then it's automated. That's nice. No, well then we need somebody to send this alert to, an owner, so to speak, so that it's in transit all the time and it's not getting lost or not getting handled. And then we close it. So this is a fairly simple solution for handling something we know how to handle. But what happens with the unknown alert? How do we approach it? How do we determine the urgency of the impact? Well, it's there, so we need to look at it. And what's the impact? How much is really affected in this? Is there a cascade effect that affects other stuff? If A goes down, do B go down, do C go down? You need to know the impact of this alert. You need to know the urgency. Is this the most important system in your business? Then you need to be on this alert ASAP. If this is not an important system, then you need to have a lower urgency on it, and you can fix it next Friday after having your second beer. So the urgency really matters when you're looking at alerts. So you need to solve and describe it. Figure out what went wrong, write down the solution so that the next person knows the solution on the problem we've just seen. And once you know the alert, you then need to figure out if it's automatable. I'm not even sure that's a word. And if it is automatable, then it's automated. Or it's not, because there is too many variations. Now you can do condition detect and condition in SCOM, and depending on the condition you can do different scripts, for example. But there is if there is too many variations, the amount of work you will use on creating this script will be huge. And then you need to look at how often do the alert happen, and there is a time. If it takes more time to create the automated solution than it does to solve the alert, thinking forward 2 years in the future, then perhaps you shouldn't use the time on automating it. Yeah. So if you cannot automate it, it needs an owner. Coming back to what I've been trying to drill in, and then it's closed. So now you have the full how to handle the unknown alert. So how do we get an efficient alert flow? We have looked at the difference between the known and the unknown alerts and how we handle these alerts. So now we need to make sure that the alert doesn't stop or stall somehow, because this will break the alert circle of life. Because in an imperfect world, alerts somehow just get sent to somebody who doesn't solve them. So what we need is of course, our SCOM platform that creates a new alert, and it hits the queue. It gets visited. Is it an unknown error? Then we send it to the team who can analyze it. And if it's a known error, well, then we instead get to the same point, which is, can we automate this one so that we don't have to handle it ourselves, because we don't want to manually handle alerts if we can get rid of that. In a perfect world, we were sitting at our desk with our feet up on the desk, leaning back, not doing a lot, because everything is automated and just working. Now, this perfect world doesn't really exist anywhere. So everywhere you go where you need to be doing something, or there's a hole that needs to be plugged because the boat is sinking and you only have 10 fingers. So if we can automate this, it will be automated. Otherwise, it will be sent to the tech guru or the owner, and it will get closed. But now we have an extra thing. We are looking for better alerts. And in order to make these better alerts, I try to imagine how the alerts get solved. What kind of extra information can I add to the alerts so that the one solving it gets the best possible work conditions? So, let's say you're making a new CPU alert. Instead of having a less functioning alert saying you have a high CPU alert, please investigate, this new alert will tell you that, well, you have a high CPU alert, and this is why. So the new CPU alert, or the improved CPU alert, shows the 5 most CPU consuming processes. It shows the process ID, it shows the name and the usage at the time of the alert. So now you are finally able to figure out what happened last Friday. It started something like this. The virus scanning started, but the backup is also running. And somehow that super important SQL job that takes days to complete failed again. So everybody is looking at everybody and everybody's pointing fingers, and the good old silo war has begun. Everybody's pointing at somebody else. Well, what if this is not one thing, but multiples that create cascades until you reach a perfect storm? And then you have this huge breakdown and you don't have one single thing to point at, but you have a lot of things. Like in a clock, there's a lot of moving pieces, and some of these are just not working. So you need to figure out what happened, but you only have some of these puzzle pieces, and you don't have nearly enough to begin to imagine the full picture. So you need to get more information, and this is an attempt to provide you with more information. This alert is also state-based, which means that it can change state, so it can auto-create an incident, and it can close the auto-created incident if the reason for the alert to begin with gets solved by other means. So this will allow you, when you're troubleshooting what happened last Friday, to see all this information, because it's readily available. It's on the server, it's on the SCOM platform, you can see it everywhere. And more information usually means better decision. Well, there's not much to say about the improved memory alert. It's an repeat of the CPU alert, just done with memory instead. It still states the 5 most memory consuming processes. It also states how much they are using individually. So these two alerts combined will enable you to start to investigate performance issues and maybe figure out what happened and why the alert appeared. So what alerts to improve? Well, the tools and methods say that the most noisy ones, I mean the ones that keep on returning, and the ones that take up most of your time. Or you could look at the business critical ones, because they add all the extra value. This can change, of course, from organization to organization. When you are able to easily count the alerts, it's very easy to see which one are the regulars. These keep on coming back and you never ask them back, but damn it if they don't stand outside your door the next day. So this can also enable you to spot other patterns of instability or to see if certain monitoring objects experience way more downtime than other similar ones. This could give you an attack angle on trying to figure out why things are unstable. What you could do is to compare two similar looking systems and try to figure out why this one system is behaving differently than the other one. So alert details. This is a standard and this is an example of a standard alert in SCOM. Once you're able to see all the alerts at once, there will be interesting patterns, like when they appear or the timing of the alerts. It also tells us what happened, how long it happened in, or for how long did it happen, and how often does it happen. We all know that troubleshooting can be like trying to solve a riddle. The more information you got, the better answers you can provide. This can also help to figure out how to improve a given alert. For example, in this alert, the alert description is not that good. It doesn't tell us anything. It can also tell us if a threshold maybe is set too high or too low, because then the alert will also trigger too much. It will create what is known as a flip-flopping monitor. And at the end, while intuition can provide a hunch or spark that starts you down a particular path, it's through data-driven decisions that you verify, you understand, and you quantify. This is how you make the better decisions and not just on your gut feeling. Even though the gut feeling can be quite good sometimes, it's not the best in IT. So, the last set of extra details include stuff such as time and state or resolution time of a given alert. So if an alert is taking a long time to solve, why is that? Can we add more information? Can we add more monitoring that makes it easier to see this pattern? In short, can we make it better? Can we somehow remove an obstacle so that we can solve it quicker? The report also shows state set by user ID, which is a fancy wordplay for who did what. And this allows us to see if it gets solved by the system or by an analyst. This allows us to talk to the analyst and try to figure out why this alert takes a long time to solve. Is there a lack of information? Is there something missing that would allow him to do his job better? So at the end of this, we have the parameters. The parameters is something each alert inherits, and this is like 10 extra fields that you can populate with values or information. So I have successfully populated these with incident numbers from our incident system, so that once we auto create an incident from SCOM, it gets back the incident number from the newly created incident and it puts it into one of these parameter value fields, and then you can show the parameter value field both in SCOM and squared up, and people can see the incident number on the alert, and then they can go into your incident system and see what's happening, and they can see that somebody is working on it from the incident creation. So this alert is being handled. This is the important thing that you're showing with this. So, alerting 101, to sum it all up. If a monitor keeps on generating too many alerts, it might need a bit of attention. This can be due to a number of things, but it's usually one of these. Wrong threshold setting, too high, too low, unstable monitored object, for example a computer that reboots spontaneously, or unstable monitoring, wrong configuration of some sort. Maybe you have created a self-healing monitor that goes into a loop. Things go down, gets restarted, goes down, gets restarted, goes down, and since it's not creating a new alert anywhere, it can take a long time for people to realize that this is happening. So what you need is to make sure that you put in a counter in your monitoring, so that, let's say, if it reboots more than 3 times in 15 minutes, then you stop auto creating and you create an alert instead. So you have an if-else structure or something like that in a PowerShell script that will say, if 3 events from the last the 15 minutes are there, then don't restart, but instead, create another alert that says that our automated workflow has failed. Look at this instead. And at the end of the day, every alert needs an owner. Alerts with a repeatable solution are good candidates for automation, and alerts with good descriptions are solvable by way more people. Do you have any questions? Do you have any comments? Feel free to hit me up on LinkedIn, on Scomathon. I will be here providing feedback and to answer your questions in the question and answering round. So very much looking forward to hearing from you all. Thank you for listening, and thank you for using the time to see my presentation. I hope you all have a very nice day. Bye bye.